Hey guys, and welcome back to another video. In this video, we're going to be differentiating the Lambda W function. So I've already made a video on integrating the Lambda W function on this channel, so I definitely recommend you check that out also. But yeah, let's get right into it. But first, let's just talk about what the Lambda W function even is, right? So basically, it's used to help solve exponential equations where the variable is both in the exponent and in the base. So basically what I mean by that is like if you have some equation like x, say e to the x, right? Then by definition, if you take the lambda w function of this, so w of x e to the x, this gives you x back, right? So in this way, w of x and x e to the x are inverse functions. Okay, good. So then now let's get right into the derivative. So we're going to begin by letting y equal w of x, and we're going to differentiate this implicitly, right? So using this equation, this identity over here, we know that if y is equal to w of x, this means that y e to the y is equal to x, right? Because then if you take w on both sides of this, then w of y e to the y, that actually gives you y, and then you get w of x, right? So you get that y e to the y is equal to x. Okay, so then now you will differentiate both sides with respect to x implicitly. So on the left hand side, we're going to use the product rule, right? So we keep the first function, so we have y, and then derivative of e to the y is just e to the y. But then remember we have to multiply by the derivative of y because of the chain rule. So then times dy dx plus the derivative of y is just dy dx times e to the y. And then this is equal to derivative with respect to x of x, so that's just 1. Okay, so then we can factor out the dy dx and we can divide both sides. So we get dy dx is equal to 1 over y e to the y plus e to the y, right? So then now notice that we can simplify this further. So we know that y e to the y, that's just equal to x, right? So we have x plus e to the y. So then now from here you can simplify this in two different ways, right? So first we can just see that, okay, y is equal to w of x. So that means that e to the y, that's just simply e to the w of x, right? So this is one form of the derivative, right? But then from here you could also go in a different path. So this is one way, and a different way is just to simply, so you still have the 1 over x plus, and then e to the y. So then now we're looking at this one. So if we solve this for e to the y, we have e to the y is equal to x over y. And then y is equal to w of x. So this is just equal to x over w of x. So then we could also substitute that in for e to the y. So we have 1 over x plus x over w of x. Okay, like that. And then we have a complex fraction, so we should multiply top and bottom by w of x to get rid of that fraction in the denominator. So I will do just that. And let's see. So we have w of x, and then in the bottom I can factor the x out. So then we get w of x over x times 1 plus w of x. Okay, like that. So this is another valid form of the answer. All right. So yeah, now we have officially integrated and differentiated the lambda w function. And then in a couple of future videos, I will actually show you how to use the lambda w function to actually solve some equations. All right. So if you found this video helpful or interesting, please make sure to leave a like and don't forget to subscribe. I'll see you guys in the next video.